Good morning, dear students and my well-wishers. How are you? I hope all are fine and healthy at your houses. Okay, today let me start intermediate first year chemistry first lesson, that is nothing but atomic structure or structure of atom. See how the textbook was prepared in linely lessons. You have to see once. First lesson is atomic structure. In this lesson we can know the structure of atom, how the structure of atom is built. It means inside the atom which things are there, where are there, those all we can know by using this lesson. And the next lesson is classification of elements and the periodic table. In this lesson we can know how many types of elements are there, I mean atoms are there. Those all atoms properties also we can know, that is periodic table. And third lesson is chemical bonding. In that lesson we can know the bonding of atoms, how the atom can bond to the another atom, we can know in that lesson. So very perfectly they designed, so we have to follow this order. So first lesson is atomic structure. Okay, let me start this lesson now. First, what is journey of atom? Journey of atom means in this lesson what we will learn. So first I will explain full lesson flow chart. How many topics are there? Total there are 12 topics, main topics. Still subtopics also there, that also I will discuss. But these main full topics let me discuss first. Okay, first atom. About atom first explained by Democritus, the scientist Democritus, he explained. After him Aristotle also explained about atom. Each and everything we can discuss clearly. First let me explain about this flow chart. Okay, after that John Dalton, he is a English British school teacher. He gave his atomic theory. He is the father of atomic theory. First atomic theory. Next, invention of subatomic particles. Actually electrons, protons, and third also there. Actually third one is neutron. Actually after completion of all these theories, at last they invented, I mean Chadwick invented neutrons, discovered the neutrons. Okay, next subatomic particles, three mainly. What are they? Electrons, protons, neutrons. Okay, we can discuss clearly later. And after that J. Thomson atomic theory. After this theory also failed. After this theory, Rutherford atomic theory, this also failed. Failed in the sense some limitations are there. To overcome that limitations, next theory will come. That is Niels Bohr atomic theory based on quantum theory of radiation. Yes. After that Sommerfeld Bohr extension theory. After that quantum mechanical model of an atom, Schrodinger wave equation. Yes. After that quantum numbers. First one principal quantum number and azimuthal quantum number and magnetic quantum number and spin quantum number. After that arrangement of electrons in an orbital. Principles are there. In that first one is Abbo principle, Pauli's exclusion principle, Hund's rule, electronic configuration of atoms. Okay, if you discuss these all topics, then this lesson will complete. This is simply about this atomic structure full lesson flow chart. Not only this, some subtopics also there, that also I will discuss. Okay, if you want to write this flow chart, then you have to write. Otherwise if you want to take screenshot, then take it. 1, 2, 3. Okay. Okay, see, first theory let me discuss, that is Democritus theory. What he told about atom? He told all the atoms are the building blocks of matter. Simply, atoms are the building blocks of all the matters. So about atom, Democritus told like this. Okay. Next, after him, Aristotle also explained about atom. He told matter is not made up of atoms. Matter is made up of four things. They are, first one is earth, second one air, third one water, fourth one fire. So matter is made up of four things. They are earth, air, water, fire according to Aristotle. But his theory many members not accepted. This theory was rejected. And after him, the third person, well-known person, he is John Dalton. He is the English British school teacher. So his theory let me discuss. The theory, he is the father of first atomic theory. Third one, John Dalton atomic theory. John Dalton atomic theory. See what he told about atom. He gave some points. I mean, first point is all atoms are, same point, building blocks of all the matters. And second point is atoms of elements are identical in the sense similar, identical in mass and properties. It means it is simply element definition. Element definition, do you know? Element in the sense the combination of same type of atoms by fixed mass is called element. So identical atoms in the sense like H plus H gives to H2. Atoms of element are identical in mass. What is the mass of hydrogen? Atomic mass of hydrogen 1. Identical, similar. And properties also, both hydrogen can show same properties. Okay, it is simply element definition. Second point is element definition. Third point, already element definition, atom definition, element definition, molecule definition, compound, mixture, these all I explained in one video. If you didn't see that video, then I will keep in cards, you have to see, and as well as I will keep in description also, have to see, then you will get clarity. Next, third point is compounds are the combination of two or more different, not same, different types of atoms by fixed mass. fixed mass. See, simply H plus Cl, combination of two or more atoms by fixed mass is called compound, HCl. Hydrogen is different from the chlorine. If you combine these two, then you will get HCl. So it is compound definition simply. Next, fourth point is during the chemical reaction, the rearrangement of atoms takes place. The rearrangement of atoms takes place. This is John Dalton atomic theory. Based on this theory, some laws developed like law of conservation of mass, law of constant proportion, law of multiple proportions, laws developed. Okay, these 4 points are very important. Fourth point, see, rearrangement in the sense like a small example I will give. AB plus CD gives us to AD plus BC. Here we didn't create any new thing, we didn't destroy anything, just rearrangement of atoms took place here. See, AB, this AB is splitted and this A joined with D and this B joined with C. Okay, this is called rearrangement of atoms. This is John Dalton atomic theory. If you want to take screenshot, then take it. Next, let me explain about invention of subatomic particles. Before going to this topic, let me say something. What is that? Already we know all the matters are made up of small particles. Those are called atoms. It means all the atoms are building blocks of all the matters. Okay. Now all the scientists showed interest towards inside the atom what are there. They have to know. So for that purpose they conducted some experiments. What are the experiments? In that first experiment is cathode ray tube experiment. Now we got clarity. Matter is made up of atoms. Okay. That atom, inside the atom, what are there? They want to know. Have you understood? Here the thing is, we know already inside the atom what are there. That is the problem. Just you have to imagine, we don't know about atom. Inside the atom what are there, we don't know. Then you will understand clearly. Okay. Okay, first cathode ray tube experiment. What is cathode ray tube experiment? See, here one diagram is there. Let me draw that diagram. It is a discharge tube made up of glass. Discharge tube. It is discharge tube. This experiment was conducted by J. Thomson. Okay, this is discharge tube. Now on the walls of the discharge tube, I will apply the fluorescent material that is called zinc sulphide ZNS. It is fluorescent material. What is fluorescent material? Zinc sulphide. What is fluorescent material? Fluorescent material in the sense, if the light ray touches the fluorescent material, then automatically it will twinkle. Okay, actually we can't see that particles. Then, but when the particles touches this fluorescent material like ZNS, then automatically it will twinkle. Just presence of particles we will know by using fluorescent material. That is the use of fluorescent material. Substance ZNS. Okay, now inside this discharge tube, actually he was taken H2 gas. or any gas, not a problem. First H2 gas you have to take. Hydrogen gas. This is, he fixed one cathode. It is cathode. Cathode having positive or negative charge, and it is anode having positive charge, positive. Okay, see, he connected this anode and cathode to the battery. High voltage he applied, 10,000 volts he applied, and here down one pressure gauge will be there. What is the use of pressure gauge? By using pressure gauge we can maintain the pressure. Here he maintained 0.01 millimeter of Hg pressure he applied. So when we applied 0.01 millimeter of Hg pressure, and when we sent 10,000 volts, then only at that time only one of the light ray is passing from cathode to anode in straight way. Now Thomson want to know why this light ray produced and why it is going from cathode to anode. He want to know the charge of the unknown light ray. So for that purpose he applied first positive electric field. When he applied positive electric field, then actually one point I have to remember, this light ray produced from cathode have negative charge. That unknown light ray is produced from cathode and it is going to anode. It means we can guess like this unknown light ray has negative nature. Then when he applied positive electric field, then this unknown light ray bent and traveled towards positive electric field. Then automatically he confirmed that this unknown light ray has negative nature. Okay, next, not only positive electric field, he applied negative electric field also, and as well as magnetic field also he applied. Then when he applied negative electric field, then this light ray has actually negative charge. Then this light ray, because of negative repelled, because of this negative nature, this negative light ray repelled from this negative electric field. Then finally he concluded that this unknown light ray has negative charge, and he kept name as negatron. But after that J.J. Stoney changed this negatron as a electron. These rays, unknown rays, are called cathode rays because they are producing from cathode anodes. So that's why these unknown rays are called cathode rays. And this point I would remember, when we applied 0.01 millimeter of Hg pressure and when we applied 10,000 volts, then only this light ray produced, remember. Okay, and after that this light ray, this cathode rays does not depend on the nature of cathode and the gas which is taken inside the discharge tube. Why not dependent? Because one point I would remember, in any matter, any substance, same kind of negative charge particles are there. That's why it's not dependent. Even this is Cathode in the sense it is prepared by using some material. In that material, negative charged particles are there, and this gas is there. In this gas, some electrons are there. So, I mean, some negative charged particles are there. So here negative particles, here negative particles, both are same. This negative particles, in any matter, same type of negative charged particles are there. So if you change the gas also, here no change he observed. Okay, if you change, instead of H2 gas, if you take any other gas, then also this cathode rays does not depend on the gas which is taken inside the discharge tube. Okay, that point I have to remember. Cathode rays does not depend on the nature of cathode and as well as the gas which is taken inside the discharge tube. That is the final conclusion. And J. Thomson able to calculate the E by M value. E by M value in the sense specific charge. It is also called specific charge of electron. E by M by using the following formula. What is the formula? E by RB square. Here E in the sense charge of electron, M in the sense mass of electron. This is E by M value. It is also called specific charge. Here this capital E is in the sense applied electric field. Here R in the sense radius, B in the sense magnetic field. Okay, by using this formula, he able to calculate the E by M value of electron. Specific charge of electron is 1.7588 into 10 power of 8 coulombs per gram. 10 power of 8 coulombs per gram. If you want to convert into kgs, then 1.7588 into 10 power of 11 coulombs per kg. Okay, 10 power of 11 coulombs per kg. Okay, see next, have you understood about cathode ray tube experiment? See, nothing. In this cathode ray tube experiment, he discovered the new negative particles. Those are called electrons. Have you understood? Okay, next one is Millikan oil drop experiment. Oil drop experiment. Millikan oil drop experiment. Okay, Millikan is a scientist. He want to calculate the charge of the electron. Already we know the E by M value of electron is 1.7588 into 10 power of 8 coulombs per grams, or 1.7588 into 10 power of 11 coulombs per kg. It is E by M value of electron. Remember, electron. We don't know individually the charge of electron and the mass of electron. We know E by M value ratio, we know. Specific charge we know. Okay, E by M in the sense specific charge, but individually we don't know. So Millikan is a scientist. He want to calculate the charge of the electron by using oil drop experiment. Okay, oil drop experiment conclusion is, he gave one formula, that is Q is equal to Ne. Q in the sense, Q means charge of oil drop, N in the sense number of electrons, integer, E in the sense charge of electron. He observed that in his experiment, the charge of the oil drop is integral multiple of charge of the electron. Charge of the electron is E is equal to 1.6022 into 10 power of minus 19 coulombs. This is the charge of the electron. Have you understood? This is simply about Millikan oil drop experiment. Now let me discuss some problems regarding Millikan oil drop experiment. In that first problem is an oil drop has 8.0, I mean 8 into 10 power of minus 19 coulombs charge. How many electrons does this oil drop has? See, according to the question given that the charge on the oil drop is 8 into 10 power of minus 19 coulombs. Now we know that by using Millikan oil drop experiment, the charge on the electron is 1.6 into 10 power of minus 19 coulombs. According to Millikan oil drop experiment, the one formula is there. What is that formula? Q is equal to Ne. Here they are asking how many electrons does the oil drop has. See, it means N value they are asking. What is the N value? How to calculate? Okay, number of electrons. N in the sense number of electrons. Q in the sense charge of the oil drop. E in the sense charge of the electron. N in the sense number of electrons. Now we want N value. Now this E have to send this side. Then Q by E. Then I have to substitute these two values in this formula. Q in the sense oil drop charge Q, electron charge E. Now Q value 8 into 10 power of minus 19 coulombs by 1.6 into 10 power of minus 19 coulombs. Coulombs cancel. 10 power of minus 19, 10 power of minus 19 cancel. Then 8 by 1.6, it means 80 by 16. It means 5 electrons. That oil drop contains 5 electrons. Okay, have you understood? Okay, see next problem. In an oil drop experiment, the charges on oil drops were found as 1.5 into 10 power of minus 15, 3 into 10 power of minus 15, 4.5 into 10 power of minus 15, 6 into 10 power of minus 15 coulombs. Calculate the magnitude of the charges on the electron. This is the problem. Okay, given that they gave 4 oil drops. What they are asking? They are asking electron charge. They are asking. Okay, 4 oil drops they gave. What are they? 1.5 into 10 power of minus 15 coulombs, and second oil drop is 3 into 10 power of minus 15. Third oil drop is 4.5 into 10 power of minus 15, and fourth oil drop is 6 into 10 power of minus 15. Okay, if you observe properly, here 1.5, 3, 4.5, 6, it is the integral multiple of 1.5. 1.5 into 2, 3. 1.5 into 3, 4. 4.5. 1.5 into 4, 6. It means this one I will write as 1 into 1.5 into 10 power of minus 15. This one I will write as 2 into 1.5 into 10 power of minus 15. This one 3 into 1.5 into 10 power of minus 15. And this one 4 into 1.5 into 10 power of minus 15. Now if you observe this one, first I will drop, then it looks like Q is equal to N into E. Okay, Q is equal to N into E. This also Q is equal to N into E. This is E. This is E. Okay, this is E. This is E. These are N values. These are Q values. Now what is the value of E? Same value. Integral multiple of N. 1.5 into 10 power of minus 15. Now what is the E value? Finally the charge of the electron is 1.5 into 10 power of minus 15 coulombs. This is the charge of electron. Have to write in notes. Next topic is calculation of mass of electron. See, for everything connection will be there. First we read about cathode ray tube experiment. In that we got one value, that is EBM value of electron. EBM value of electron is equal to 1.7588 into 10 power of 8 coulombs. Okay, this is EBM value, specific charge of electron, but we don't know particularly, I mean individually, charge of electron, mass of electron. But charge of electron again, who calculated, who proposed? Charge of the electron was proposed by Millikan. So charge of electron E is equal to 1.6 into 10 power of minus 19 coulombs. Okay, now we don't know again about the mass of the electron. We have EBM value and we have E value also. Now let you calculate M value, I mean mass of the electron. How can you calculate? Simply I want M value. This M how I will write? See, E by 1 by E by M. E by 1 by E by M. See, this M, if you send, it will go to upside, then E M by E. E will cancel, then you will get M. So M I am writing in this way. Okay, see, next here see, E by 1 in the sense E by E by M means E by M, just 1 I removed. Okay, see next, charge of electron we know already. What is the charge of electron? 1.6 into 10 power of minus 19 coulombs by E by M value of electron also we know, 1.7588 into 10 power of 8 coulombs. Sorry, here coulombs per gram. Coulombs per gram. Here also gram. Okay, here coulomb will cancel. Then see, the mass of the electron is 9.1096 into 10 power of 28 minus 28 grams. If you want to convert this one into kgs, then 9.1096 into 10 power of minus 31 kg. We know already 1 kg is equal to 1000 grams. Okay, you have to remember this point. EBM value of electron is always constant. Its value is 1.7588 in 10 power of 8 grams or 1.7588 in 10 power of 11 kgs. It always constant for any matter. I mean in any matter, same kind of negative charge particles are there. So it is fixed for all the negative charged particles. EBM value, remember. Okay, it does not change. It is always constant. Next small problem is there. That is find the EBM value of alpha particle. What alpha particle? He plus 2. Answer is E by M. The charge of He is 2 and atomic mass of helium is 4. He 2 4. Okay, it is atomic number, it is atomic mass. Atomic mass is 4. Then 2 by 4 in the sense 1 by 2. It means 0.5. So EBM value of alpha particle is 0.5. Remember. Now let me say invention of proton. Invention of proton. Invention of proton by anode ray tube experiment. Anode ray tube experiment. Anode ray tube experiment. See here, actually when the cathode ray tube experiment is going on, at that time only some of the positive charged particles are coming from anode to cathode, but they didn't observe. Actually it is discharge tube. Fluorescent material will be gelatinous. Okay, then these are the electrodes. Okay, pressure gauge 0.01 millimeter of Hg and 10,000 volts, and here some of the particles travel from cathode to anode, cathode to anode, cathode negative, anode positive. At that time only actually some of the rays travel from anode to cathode also, but they didn't observe. It was observed by the scientist Goldstein. Okay, see, actually Goldstein made holes to the cathode. It is called performated cathode. Performated cathode. It means the cathode contain holes is called performated cathode. So these rays travel from anode to cathode. I mean, these are negative rays. Already we read in cathode ray tube experiment. These are positive rays. These positive rays actually initially in the cathode ray tube experiment nobody didn't observe, but Goldstein is the scientist. He observed some of the positive rays are traveling from anode to cathode, and these rays travel through these holes and it touches the discharge tube containing fluorescent material, then automatically it will glow. Then Goldstein you want to study about these positive rays. Why positive rays? Actually first we don't know what is the nature of these rays. Okay, so he applied first negative magnetic field and negative electric field also. Then these rays bended towards negative electric field and traveled. Okay, actually these are traveling in straight way, but when he applied negative magnetic field, then it bended towards negative magnetic field because it have positive charge, that's why bended. So he concluded that it have this unknown light ray have positive charge. For example, I am saying in this discharge tube, one of the A is one of the atom. Okay, now it released some electrons because of this high voltage and this low pressure. It released some electrons, then it became positive ion because it lost some electron, it emitted some electrons. Okay, now these are positive ions, these are electrons same in all matters. So E beam value is constant of electrons. Okay, and here positive charged particles are there, positive charged particles. These positive charged particles can change from one matter to another matter, because in this not only positive charged particles, in that again neutrons are there, some more things are there. That's why if you take another gas, positive charge will change, but electrons won't change. Electrons same, but positive charged particles will change. For example, B there, B, it emitted some electrons, Now it got positive charge. This is ion. Now here electron same, this electron same, but this B plus A plus not same. So here in cathode ray tube experiment E beam value constant, but in anode ray tube experiment E beam value of anode rays not constant. It will change from one gas to another gas because different types of ions. Remember, different types of ions. Okay, but electron same, but from gas to gas positive ions are different. Remember, these positive charged particles are also called anode rays or canal rays. Anode rays or canal rays. Okay, now E beam value of cathode rays, I mean electrons, negative charged particles is greater than E beam value of positive charged particles, I mean anode rays. Okay, see here actually charge is same. According to Millikan's oil drop experiment, charge is for the electrons minus 1.6 into 10 power of minus 19 coulombs. For the protons plus 1.6 into 10 power of minus 19 coulombs. Okay, but why the E beam value of electron got more value than the E beam value of anode rays? Charge is same, so the difference is there in the mass of the electron and mass of the anode rays, mass of the cathode rays and mass of the anode rays. See here, for example, for understanding purpose, here E value I will assume as 10. E value is 10. Okay, because same value. So E value is 10. I fixed E value 10. E value of cathode rays is 10. E value of anode rays is 10. Okay. Now E value, this value is more. When it will become more? See, based on the down number. Okay. Did you understand? Denominator number is here. If I take 2 and here if I take 5, then it will become 5 is greater than 2. 5 is greater than 2. Have you understood? It means, what is the clarity here? The mass of the electron is less. Mass of the electron is less than the mass of the proton. Okay, mass of the electron is less than the mass of the proton. See, that's why we got E beam value of electron is greater than the E beam value of proton. Have you understood now? How many times lesser? 1837, nearly 2000 times lesser than the mass of the proton. This point I have to remember, very important. Nearly, it is nearly. Okay, mass of the proton is higher than the mass of the electron, and mass of the electron is lesser. How many times lesser than the proton? 1837 times lesser, or nearly 2000 times lesser than the proton, mass of the proton. This point I have to remember, very important. Okay, next one is E beam value of proton is 9.58 10 power of 7 coulombs per kg. E beam value of proton for the hydrogen. What is hydrogen? Remember, hydrogen gas. Okay, for the hydrogen gas. Okay, this is simply about cathode ray tube experiment and anode ray tube experiment. Next, let me discuss further thing. Rutherford able to conducted one experiment between nuclear reaction experiment between nitrogen 714 and with alpha particle. He24 is called alpha particle. He bombarded alpha particle with nitrogen nucleus, then he got proton with oxygen isotope, one of the isotope. Okay, this is called proton. Okay, now this proton discovered by, who discovered the proton? Rutherford discovered the proton. And who discovered the electron? Electron was discovered by J.J. Thomson. J.J. Thomson discovered the electron. Remember, Rutherford discovered the proton. Okay, have you understood? Next, Rutherford suggested that inside the atom one more subatomic particle is there. Okay, that subatomic particle may not have any charge. Like that he suggested. Based on his suggestion, another scientist, his name is James Chadwick. He conducted on nuclear reaction between beryllium 9 and alpha particle. He bombarded alpha particle with beryllium nucleus. Then he got neutron with carbon atom 6 and 12. Okay, this is called neutron. Okay, so this neutron unwanted particle, actually first nobody don't know, he don't know, who Chadwick don't know, this is unwanted particle. So he introduced this unwanted particle into positive electric field and negative electric field, but even though no response, it not bended to anything, any side. Okay, it not bended to any side. Then finally concluded that it is neutral. Okay, it doesn't have any charge, it is called neutron. Have you understood? Okay, and the mass value of neutron is, it is slightly greater than mass of the proton. Mass of the neutron is 1.675 10⁻⁻24 grams. It is nearly equal to the proton, nearly equal to mass of the proton. Okay, mass of the proton, remember. Next one is E-beam value of neutron. E-beam value of neutron is E value, charge 0, neutron charge 0. M value, mass of the neutron 1.675 into 10⁻⁻24 grams. Okay, then 0 by anything 0. E-beam value of neutron is 0. Next topic is comparison between subatomic particles. What are the subatomic particles? Mainly 3: electron, proton, neutron. Comparison we have to see. First, subatomic particle discovery, mass, relative mass, charge, relative charge, E-beam value. Electron, who discovered? J. Thomson. Proton, who discovered? Rutherford. Neutron, Chadwick. Okay, mass value 0.0054 AMU, atomic mass unit. One atomic mass unit is equal to 1.6 into 10⁻⁻27 kg. Then if you substitute this value here, then you will get this value. Next, relative mass 1/1837 times lesser than proton mass. Okay, next, charge -1.6 into 10⁻⁻19 coulombs, or -4.8 into 10⁻⁻10 ESU. ESU means electrostatic unit. Next, relative charge -1, electron relative charge -1. E-beam value 1.7588 actually, but roughly we can write 1.76 into 10⁻11 coulombs per kg. Next, proton, Rutherford value 1.00728 AMU, atomic mass unit. If you convert, then we will get 1.673 into 10 power of minus 27 kg. Relative mass 1. Charge here minus 1.6, here plus 1.6, that is only difference. Into 10 power of minus 19 coulombs. And 4.8 into 10 power of minus 10 ESV, electrostatic unit. Relative charge is 1. Even value of proton is 9.58 into 10 power of minus 10 power of 7 coulombs per kg. And a neutron discovered by James Chadwick. Its mass is 1.00865, slightly, which is more, you have to see here, as compared to proton and neutron mass is somewhat more. And relative mass is 1. Charge 0. Neutron doesn't have any charge. Then relative charge 0. And E-beam value 0 by anything 0. E-beam value also 0. Have you understood? Okay, then write in notes or take the screenshot. If you like this video, then please press the like button. And if you have any doubts, then please post in the comment section. And please subscribe my channel and press the bell icon and keep it in all option. If you do this one, then when I will upload new videos, then automatically you will notify from my channel. And really many members are encouraging me in great way, and many members are subscribing my channel in great way. I don't want to say just thank you for you, because it's not enough, not at all enough. So I want to say one word, that is love you all. And Corona made us to learn many things, like money is not important, winning of many persons' heart is very important. So stay home, be safe, all the best, see you soon.